Hello, my dear students. Welcome back to IK Sir Chemistry classes. We are in lecture number 5 on redox reactions. So far, we have learned to calculate the oxidation number of an element in various molecules and ions. In this video, we will discuss the nomenclature of inorganic compounds based on oxidation number. Let us start our discussion with the nomenclature of metal oxides. If a metal forms oxides in two different oxidation states, the name of the oxide in the lower oxidation state is written by putting the suffix "-s after the name of metal, while the name of the oxide in the higher oxidation state is written by putting the suffix "-ic after the name of metal. On the other hand, in the IUPAC name of the metal oxide, the oxidation number of metal is written within a small brackets in Roman numerals just after the name of metal. Let us illustrate above 3 points taking some examples. Copper forms two oxides, Cu2O and CuO. The oxidation number of copper in Cu2O is +1, while that in CuO is +2. It is obvious that Cu2O is the oxide of copper in lower oxidation state, while CuO is oxide of copper in higher oxidation state. Therefore, the name of Cu2O will be cuprous oxide, as while the name of CuO will be cupric oxide. The name of oxide in the lower oxidation state ends with suffix "-s, while the name of oxide in higher oxidation state ends with suffix "-ic after the name of metal. During writing the IUPAC name, the oxidation number of metal is written within a small brackets in Roman numerals just after the name of metal without any gap. There is no gap here. Thereafter, oxide is written with a single space, copper 1 oxide, because the oxidation number of copper is 1. On the other hand, the name of CuO is copper 2 oxide. The oxidation number of copper is +2 here. Another example, iron forms two oxides, FeO and Fe2O3. The oxidation number of iron in FeO is +2, while that in Fe2O3 is +3. Accordingly, the name of FeO will be ferrous oxide, while that of Fe2O3 will be ferric oxide. The name of oxide in the lower oxidation state ends with suffix "-s, while the name of oxide in higher oxidation state ends with suffix "-ic after the name of metal. And the IUPAC name of FeO will be iron 2 oxide, while that of Fe2O3 will be iron 3 oxide. It must be noted that the name of metal and the oxidation state are written without any gap, without any space. Thereafter, a single space is given and oxide is written. Let us see some more example. Lead forms two oxides, PbO in oxidation state +2 and PbO2 in oxidation state +4. Accordingly, the name of PbO will be plumbous oxide, while that of PbO2 plumbic oxide, and the IUPAC name lead 2 oxide and lead 4 oxide. Very simple. Compound oxides. Now the question arises, what are compound oxides? There are some oxides in which the metal is present in two different oxidation states. These are called compound oxides. Their names are written as follows. Fe3O4 is actually made up of FeO and Fe2O3 in oxidation state +2 and +3 respectively. FeO is ferrous oxide and Fe2O3 is ferric oxide. Therefore, the name of Fe3O4 is written as ferroso-ferric oxide. Ferrous oxide plus ferric oxide give ferroso-ferric oxide, and its IUPAC name will be iron 2,3 oxide. Another example, Pb3O4 is made up of 2 PbO and PbO2. Here the oxidation state of lead is +2, while in PbO2 the oxidation state of lead is +4. It is plumbous oxide and PbO2 is plumbic oxide. Therefore, the overall name of Pb3O4 is plumbo-plumbic oxide, and its IUPAC name is lead 2,4 oxide. Nomenclature of metal halides. The name of metal halides in which metal is present in two different oxidation states are written in a similar manner. Let us see a few examples. Tin forms two chlorides, SnCl2 and SnCl4. Here the oxidation state of tin in SnCl2 is +2, while that in SnCl4 is +4. Accordingly, the name of SnCl2 is stannous chloride, while that of SnCl4 is stannic chloride, and IUPAC names of these compounds are tin 2 chloride and tin 4 chloride. Here also the oxidation state of metal is written within a small brackets in Roman numerals just after the name of the metal. Mercury forms two chlorides, Hg2Cl2 and HgCl2. The oxidation state of mercury in HgCl2 is +1, while that in the oxidation state of mercury in Hg2Cl2 is +1, while that in HgCl2 is +2. Its name is mercurous chloride, and it is mercury chloride. The suffix "-us" is written for the chloride in lower oxidation state, while the suffix "-ic" is written for the chloride in higher oxidation state. Its name IUPAC system will be given mercury 1 chloride and mercury 2 chloride. Now the time for self-assessment. Write down the chemical formula of cuprous chloride. Try to write down the formula of cuprous chloride. Here is the answer. We have seen in the earlier slide that the chemical formula of mercurous chloride is Hg2Cl2. Based on this fact, the chemical formula of cuprous chloride in most of the books is written as Cu2Cl2, but it is totally wrong. The actual formula of cuprous chloride is CuCl. Now the time for another question, another self-assessment. Write down the name of the following compounds: Ga2Cl4 and Fe3Br8. Here are the answers. Ga2Cl4. On normal calculation, we get the oxidation state of gallium equals to +2, but it is not correct. Gallium is a p block element belonging to group 13. It has 3 valence electrons, and according to inert pair effect, its oxidation state can be +1 or +3, and it can never be +2. Therefore, +2 is wrong oxidation number of gallium in Ga2Cl4. Actually, Ga2Cl4 is made up of GaCl in +1 oxidation state and GaCl3 +3 oxidation state, gallous chloride and gallic chloride. Therefore, the name of Ga2Cl4 is galliso-gallic chloride, and its IUPAC name is gallium 1,3 chloride. Fe3Br8, it actually consists of FeBr2 and FeBr3, ferrous bromide and ferric bromide. Therefore, its name is ferroso-ferric bromide, and IUPAC name is iron 2,3 bromide. Nomenclature of oxyacids. If an element forms oxyacids in 2 different oxidation states, the name of the oxyacid in the lower oxidation state ends with suffix "-as", while the name of oxyacid in the higher oxidation state ends with suffix "-ic". Let us see. Sulfur forms 2 oxyacids, H2SO3 and H2SO4. The oxidation state of sulfur in H2SO3 is +4, while that in H2SO4 is +6. This is lower oxidation state, this is higher oxidation state, and the name of oxyacid in lower oxidation state ends with suffix "-as", while the name of oxyacid in higher oxidation state ends with suffix "-ic". Therefore, H2SO3 is sulfurous acid, while H2SO4 is sulfuric acid. Nitrogen forms 2 oxyacids, HNO2 in +3 oxidation state and HNO3 in +5 oxidation state. This is lower oxidation state, this is higher. Its name is nitrous acid, and HNO3 is nitric acid. The name of salt of "-as" acid ends with suffix "-ite", while the name of salt of "-ic" acid ends with suffix "-ate". It means "-as" is replaced by "-ite", while "-ic" is replaced by "-ate" during writing the name of salt of oxyacid. Let us see some example. Na2SO3, it is the salt of sulfurous acid, and therefore its name is sodium sulphite. "-as" is replaced by "-ite". Na2SO4 is the salt of sulfuric acid, therefore its name will be sodium sulphate. Here "-ic" is replaced by "-ate". Let us see some more examples. NaNO2, it is the salt of nitrous acid, and therefore the name of NaNO2 is sodium nitrite. Here also "-as" is replaced by "-ite". NaNO3 is the salt of nitric acid. Its name will be sodium nitrate. "-ic" is replaced by "-ate". Very simple to write down the name of salts of oxyacids. If an element forms oxyacids in three different oxidation states. Their names and the names of their salts are written as follows. Phosphorus forms three oxyacids H3PO2, H3PO3 and H3PO4 in +1, +3 and +5 oxidation states respectively. The oxyacid of phosphorus in +3 oxidation state is written as phosphorus acid, as acid, while H3PO4 has the name phosphoric acid. This is lower oxidation state, this is higher oxidation state. Lower oxidation state as acid and higher oxidation state ic acid. Again, what about the oxyacid of phosphorus in +1 oxidation state? Its name is hypophosphorus acid, which means lower oxidation state than phosphorus acid. The oxyacid of phosphorus in which the oxidation number of phosphorus is lower than that in phosphorus acid. Hypo means less, low. The names of salts of these oxyacids are written as follows. NaH2PO2 is the salt of H3PO2, hypophosphorus acid. Accordingly, its name is sodium hypophosphite. Na2HPO3 is the salt of H3PO3, phosphorus acid. Its name is sodium phosphite. Similarly, Na3PO4 is the salt of H3PO4, phosphoric acid, and hence its name is sodium phosphate. If an element forms oxyacids in 4 different oxidation states, their names and the names of their salts are written as follows. Chlorine forms 4 oxyacids HOCl, HClO2, HClO3 and HClO4 in oxidation states +1, +3, +5 and +7 respectively. It is written as acid, ic acid, chlorous acid, it is chloric acid, and the oxyacid of chlorine having oxidation state of chlorine even lower than acid is hypochlorous acid. And what about perchloric acid? It means higher oxidation state, higher state of oxidation than chloric acid. The oxyacid of chlorine in which the oxidation number of chlorine is greater than that in chloric acid is called perchloric acid. The names of salts of these oxyacids are given below. NaOCl, the salt of HOCl, that is hypochlorous acid, is sodium hypochlorite. Accordingly, in a similar fashion, the name of NaClO2 is sodium chlorite. NaClO3 is the salt of HClO3, that is chloric acid, and hence its name is sodium chlorate. And what about NaClO4? It is the salt of HClO4, that is perchloric acid, and therefore its name is sodium perchlorate. Nomenclature of complex compounds. The oxidation state of central metal atom or ion plays an important role in the nomenclature of complex compounds. Here also, the oxidation state of the central metal atom or ion is written within small brackets in Roman numerals just after the name of the coordination sphere. The oxidation state of central metal atom or ion is written within a small brackets in Roman numerals just after the name of coordination sphere. Please note that the name of a coordination sphere is written as a single word, and the name of coordination sphere ends with the oxidation number of its central metal atom or ion in Roman numerals in small brackets. Let us see some examples. NiCO whole 4. Here there is no charge on carbon monoxide. Overall charge is also 0. Therefore, the oxidation state of nickel in NiCO whole 4 is 0. Its name is tetracarbonyl nickel 0. Single word. It is coordination sphere and its name is written as a single word without any space. The oxidation state of nickel is written in Roman numerals within small brackets just after the name of coordination sphere. Here no gap, no space is given. Another example, CuNH3 whole 4 SO4. There is no charge on NH3 molecule. Sulfate ion contains 2 minus charge. It means the oxidation state of copper is +2 and its name is tetraamine copper 2 sulfate. The name of this coordination sphere is written as a single word, and the name of coordination sphere ends with the oxidation state of central metal ion in Roman numerals within small brackets without any space. Sulfate is counterion and sulfate is written after a single space. Another example, Na4FeCN whole 6. Here the oxidation state of Fe is +2 on calculation because the oxidation state of sodium alkali metal is +1 and there is 1 minus charge on Cn minus ion. On calculation, the oxidation state of iron comes to be +2 and its name is sodium. The name of the coordination sphere is written as a single word, hexacyanoferrate, and it ends with the oxidation state of central metal atom or ion in Roman numerals within small brackets without any gap. These are some examples for the nomenclature of coordination compounds. Now, time for another self-assessment. Write down the IUPAC name of the compound FeH2O whole 5 NoSO4. It is well known compound. It is the brown ring complex formed during the ring test of nitrate ion. There is no charge on H2O molecule. NO is present as nitrosonium ion having 1 plus charge. Sulfate ion has 2 minus charge. Therefore, the oxidation state of iron will certainly be +1 and its IUPAC name is penta-aqua nitrosonium iron 1 sulfate. Very interesting compound. Penta-aqua nitrosonium iron 1 sulfate. Thank you for watching the video with concentration. Please like, share and subscribe so that encouraged from it I may bring more useful videos before you in future. We will meet soon with oxidation number concept of oxidation and reduction and discussion about oxidizing agent and reducing agent. Thank you again.